All right, this one, we're going to do the fourth and final video for 7.2. This is the very bottom of the backside of 7.2, where we have power of a quotient. This really is exactly like your power of a power rule. If you have a fraction and you raise it to an exponent, in this case it's, say, if you raise it to the n, well then you take everything on the inside, the top and the bottom, and you raise them to the n. So this is going to equal x raised to the n over y raised to the n. So power of a quotient, you're really just multiplying the exponents. You know, this is like saying x to the first, this is like saying y to the first. So n times 1 gives me n. So power of a quotient, again, the key is, it's just like power of a power. You multiply exponents, but now you do it twice. You do it for the numerator, and you do it for the denominator. All right, let's look at number 1. Now, number 1, again, don't forget about the numbers, the coefficients. This is like saying 3 to the first. So when I multiply this 1 and this 2, it gives me 2. So it becomes 3 squared. When you multiply this 4 and this 2, you get x to the 8th. And then this, the bottom, is like saying 4 to the first. So 1 times this 2 gives me 2, so it's 4 squared. And then if I just evaluate, let's see, 3 squared, remember that's not 6, it's 3 times 3, which is 9. So I have 9x to the 8th. 4 squared is 16, because that's 4 times 4. The 9 over 16 does not simplify, so that's it. That's your answer. Okay, the second one, right, I look at the 5. That's to the first, so 1 times this 2 gives me 5 squared. This 5 times this 2 gives me 10, so it's x to the 10th. Y is the same as saying y to the first, so 1 times this 2 gives me 2, so that's y squared. And then this 6 is just like saying 6 to the first, so same thing again. 1 times this 2 gives me 2, so it's 6 squared. And let's see here, 5 squared is 5 times 5, which is 25. So we get 25x to the 10th, y squared. 6 squared is 6 times 6, which is 36. And nothing simplifies there, so that's our answer. Okay, I move to number 3. Number 3, again, I'm going to take this 4, I raise it to the first, so 1 times this 3 is 3, so I get 4 cubed. Then this 3 times this 3 is 9, so I get x to the 9th. Okay, don't forget about the 5 to the first, so 1 times this 3 is 3, so it's 5 cubed. And then this is 4, that's an exponent, 4 times 3 is going to give me 12, so it's y to the 12th. And then if I evaluate this, let's see here, 4 cubed is 64, you could use your calculator for that, x to the 9th, over 5 cubed, you would definitely use your calculator, that's 125, and that's y to the 12th. And remember, I cannot subtract these exponents because they're a different base of x and of y. The very last one, you really don't even have to do anything to. This goes back to our 0 exponent. Don't be fooled by this. It's almost kind of a trick question. If you take any quantity and you raise it to the 0, it automatically equals 1. So that's it. You could have 15 different terms on the inside, but if it's raised to the 0, it equals 1. The other way of looking at it, here's the long way, which I really don't want you to do, but I'll just show you real quick. This is like saying x to the first. Well, even if you do power over power, if you multiply this 1 and this 0, well, 1 times 0 is 0, so you get x to the 0. You're going to get y to the 0, z to the 0. Well, anything to the 0 is 1, so 1 over 1 just gives you 1. So save you all time and effort. I wouldn't even do this. If any quantity is raised to the 0, it equals 1. All right? So really, power of a quotient is the same exact thing as power of a power. You multiply the exponents, but you got to do it twice. One for the numerator, and everything for the denominator. Multiply the exponents.